Electronics question based on number systems representation. We have been given the IEEE 754 single precision floating point format with a bias of 127. The sign bit, exponent bit, and the fractional part, or you can say the mantissa, has been given to us, the 32-bit representation. And we need to determine the value of the floating point number denoted in this format. Up to 2 decimal places, the result has to be rounded off. So let us see. We'll be following the implicit normalization form, and bias is already given to us as 127. So the result would be the sign bit minus 1 raised to the sign bit into 1 point, since we are using the implicit normalization. So 1 point mantissa, which is this bits, and it starts from this side, from left to right instead of right to left, and that into 2 to the power exponent. Exponent is the one which is given to us minus bias, which means minus of 127. This would be the resulting value. Let us compute what it turns out to be. Minus 1 raised to s. S is the sign bit, it is set to 1. So here it will be 1. The result would be a negative number. Into 1 point mantissa. What is mantissa? First 4 bits are 1 and rest all of them are 0. In total this would be 23 bits. This is 1 bit and this is 8 bits. In total they make up 32 bits. So from these 23 bits, just first 4 are 1s, rest all are 0s. So we can just write it up to this point. There is no need to write any 0s because anyway they do not have any value. And hence now we can go for the exponent part, which would be 2 to the power. Now this exponent, it is an 8-bit number whose value we can check to be, this is the last bit 128 it corresponds to, and this is corresponding to 1. So this number is 129, and from that we will be subtracting the bias, which is 127. So result is 2. And now when we go to evaluate this is minus 1 into 1 point followed by 4 ones, and then we have 2 in the exponent part, which means this can be shifted, this decimal point can be shifted 2 places ahead. That would become 111.11 because this point has been shifted to this place and to this place. 2 places have been shifted because of this exponent. Hence this is our result. Now we can simply convert this into decimal and see what it is. The result would be negative, hence the minus sign, and when we convert this number to negative 111.11, here we use the usual weights, 2 to the power 0, 2 to the power 1, 2 to the power 2, and on this side we use the weights as 2 to the power minus 1, 2 to the power minus 2, that way. So result is 1 times of 2 squared, which is 4, plus 1 times of 2 plus 1 times of 1 plus on this side 1 times of 2 to the power minus 1 means half plus 1 by 4. This becomes 4 plus 2 6 plus 1 7 plus half and 1 by 4, so 3 by 4. That becomes 7.75, and the result will be negative. Hence the answer for this question is minus of 7.75. It was a numerical type question, so this is the answer that has to be reported, and it is already having just 2 decimal places, so there is no need to further optimize it or round it off. This can be entered as the correct answer.